Welcome back to our course on ME22088 Vibration and Noise Control. I am Sendamarakannan, Associate Professor in the Department of Mechanical Engineering. In this lecture, we are going to explore the diverse range of equipment and processes that can contribute to noise pollution within industrial setting. Recognizing these different types of sources is the first and most important step in effectively controlling the noises. And in the last, we are also going to see the noises in the city and effect of the noises in the city on humans. In this lecture on industrial noise control, we will be focusing specifically on the common noise sources that originate from machinery within industrial settings. Our goal is to explore typical noise generated by various machines that encounter in industrial plants. We will be delve into how these machines actually produce sound and what the characteristics of the noise may be. Understanding these fundamentals is absolutely vital. It forms the basis for effectively managing the risk associated with workplace noise exposure and ultimately for creating healthier and more productive work environments. In the following segments, we will be covering specific examples including the noise generated by industrial gas jet, fans, compressors, woodworking machineries, and so on. Let's start by taking a closer look at one of the common industrial noise source, gas jets. You will find this used in a variety of applications. They can be quite significant contributor to the overall noise level. Typically, it is characterized as broadband noise, meaning it spans a wide range of frequencies. However, dominant portion of the noise energy usually falls within the 2 to 4 kHz. This is primarily due to turbulence and shearing stresses created as the high-speed gas stream interact with the surrounding air. Think of sink sound you might associate with escaping compressed air. That's a good mental picture. Where do we commonly find these noisy gas jets? They are used in a surprising number of industrial processes. Includes cleaning the parts, drying surfaces, and for compressed air blow off to remove debris. You also encounter them in steam balls and even in burners. Very important thing is the noise level is reaching around 105 decibel at a distance of just 1 meter. That's a significant noise level with the potential for hearing damage over a time. Now let's see upon how the noise is generated, that is noise mechanism. Interestingly, the high frequency component of the noise tend to originate right near the exit of the nozzle where the gas is expelled at high velocity. On the other hand, lower frequency noise is generally produced further downstream as a larger scale turbulence develop in the expanding gas jet. Understanding this difficult and different mechanism can be helpful when considering noise control strategies. Moving on, the next thing, very common source of noise in industrial environment comes from ventilators and exhaust fans. These are essential for maintaining air quality, removing dust, facilitating drying processes, and providing cooling in very industrial applications. As you can see here, fans are primarily used for large volumes of air. This movement is crucial for ventilation, for extracting dust and other airborne particles, for drying materials or products, and for keeping equipment and workplaces cool. Because they handle such a large airflow, they inherently have the potential to generate significant noise. Where does this noise come from? There are few key sources. Firstly, we have broadband aerodynamic noise, which is continuous rushing sound created by the turbulent airflow as the fan blade move through the air. Secondly, the fan often produce discrete tones. A fan often produce discrete tones, that is, how many times each blade passes a fixed point per second, and its harmonics, which are multiples of the frequency. Finally, we can also have mechanical noise originating from the mounting of the fan itself and its bearing, which can produce vibrations and rattling sounds. Interestingly, the sound power level generated by fan often be predicted relatively early in project's design phase. One method for doing this involves using Graham equation, which is a formula that takes account of various fan parameters. Additionally, using octave band data, which breaks down the noise into different frequency ranges for different types of fans, allows engineers to estimate the noise impact and plan for necessary noise control measures. This proactive approach is crucial in designing quieter industrial spaces. Let's turn our attention to compressors, another significant source of noise in many industrial facilities. There are various types of compressors and they all tend to generate substantial noise. We encounter several types of compressor in industrial application. This include rotary positive displacement compressors, gear or screw compressors, reciprocating compressors. Each of this type operate using different mechanisms to compress gases, and consequently they can exhibit slightly different noise characteristics. However, a common thread across most compressors is that they generate high sound pressure levels, often exceeding 105 decibel. This is very significant noise level. Furthermore, compressor noise is often periodic in nature, meaning it has a repeating pattern. This periodic noise frequently contain distinct tones, which are specific frequencies that stand out along with their harmonics, which are multiples of those fundamental frequencies. This quality can make compressor noise particularly noticeable and potentially more irritating. Next one is electric motors, which are the workhorse of many industrial processes. While essential, they can also be significant contributor to the overall noise environment. Firstly, a common and often dominant source of noise in electric motor is broadband aerodynamic noise. This is generated by the movement of air produced by the motor cooling fan as it spins and forces air through the inlet and outlet vent. This airflow creates turbulence, resulting in a broad spectrum of noise frequencies. The second thing is discrete frequency component. Generally, electric motors can also produce discrete frequency components, which are more tonal sounds. These are primarily caused by the blade passing frequency of the motor's cooling fan. Just like with larger industrial fans, as each blade passes a fixed point, it creates a pulse of air, and this regular pulsing generates specific frequencies and their harmonics, leading to a more noticeable whine or hum. The third noise is mechanical noise. Finally, this is type of noise can generate from various factors within the motor itself. Bearing vibrations, for instance, can transmit noise through motor structure. casing resonance, where the motor housing vibrates at its natural frequency. Additionally, issues like shaft misalignment or problem with how the motor is mounted can also introduce vibrations and contribute to the overall noise output. The next important thing is woodworking machines. Anyone who has been near a wood shop knows they can generate significant amount of noise from a variety of sources. The first one is structural vibration. One major source of noise in woodworking machinery is structure vibration. As the cutting tool interacts with the workpiece, it induces vibration not only in the tool itself, but also in the workpiece and even the frame of the machine. This vibration can then radiate sound into the air and thus in effect amplified if any of these components vibrate at their resonant frequencies, leading to louder and more pronounced tones. Think of buzzing or humming sound you might hear from a saw blade cutting through the hood. The second one is labeled as aerodynamic noise. Another significant contributor is aerodynamic noise. This noise is generated by the turbulence created from the rapid rotation of the cutting tool itself. As the tool spins at high speeds, it disrupts the airflow around it and around the workpiece. This turbulent airflow produces a broadband noise signature, often described as whirring or hissing sound. The last one in woodworking noise is fan dust removal. Finally, this is the very common feature in many woodworking machine. It is a dust removal system that uses a fan to carry away sawdust and wood chips from the cutting area. This fan, much like the industrial and motor cooling fans we discussed here, this high-speed movement of air carrying the particles creates additional aerodynamic noise, which can be significant component of the overall sound produced by the woodworking machines. Finally, it is pneumatic tools, widely used across various industries for tasks like fastening, grinding, demolition. These tools are often characterized by their high noise levels, and this noise originates from several key sources. The first one is contact noise, one significant contributor. This noise is generated by the direct physical interaction of the tool with the workpiece. The vibration created during processes like hammering or grinding are transmitted through the tool and radiate sound into the air. This type of noise is often particularly prominent in the mid and high frequency ranges. The second one is exhaust air noise. Another major source of noise from pneumatic tool. These tools operate using compressed air, and as this high pressure is expelled from the tool's motor and exhaust ports, it creates significant turbulent airflow. This rapid and chaotic movement of air generates a broad spectrum of noise, often described as sing or roaring sound, which can be dominant component of the overall noise signature. At last, tool vibration noise is the pneumatic source of noises. The internal airflow within the tool driving its mechanical components induces vibrations in the tool structure itself. This vibration then radiates sound into the surrounding environment. Characteristic of this noise depending on the specific design and operation of the tool. Let me summarize and wrap up various noises in the industries. As we discussed, a significant number of industrial machines produce very high noise level frequently exceeding 100 decibel. This poses substantial risk to the hearing of individuals working in these environments. We have also explored common mechanisms behind the generation of this industrial noise. This include aerodynamic turbulence, which we saw in fans and gas jets, mechanical vibrations in motors and woodworking machines, and the presence of discrete tonal components particularly noticeable in fans and compressors. Understanding this underlying mechanism is crucial for developing targeted noise reduction strategies. Fortunately, there are various control strategies that can be implemented to reduce noise exposure in industrial environments. This includes use of silencers to attenuate exhaust noise from pneumatic tools, vibration isolation techniques, and careful design considerations during the engineering phase to inherently reduce noise generation at source. We are shifting our focus from industry settings to more familiar soundscape of a typical city or town. Urban environments are often a mix of various sounds. Understanding the primary sources of this noise is the first step in addressing urban noise pollution. Arguably, most dominant source of noise in most urban areas is road traffic. This encompasses the sound generated by a wide range of vehicles, including cars, trucks, buses, and motorcycles. The characteristic sound of road traffic is often continuous, particularly during peak hours as the flow of vehicles is constant. However, this continuous hum is frequently punctuated by intermittent bursts or louder sounds, such as car horns or noise of vehicles accelerating. Generally, road traffic noise is loud, especially in close proximity to major roads and highways. Another significant contributor to urban noises is the presence of construction sites. Ongoing construction activities are inevitable. These sites generate a considerable amount of noise. Characteristic sound of construction is typically loud and highly intermittent. It's often characterized by distinct impact sounds like hammering, pile driving, abrasive noise of grinding, and the low frequency number of heavy machinery operating on sites. Another contributor to the noise environment in or near urban area come from industrial activities. Factories, manufacturing plants, and other industrial facilities located on the outskirts of a city can still impact the overall soundscape. Characteristic sound of industrial noise can vary. It might be continuous, such as the steady hum of operating machinery or the constant drone of large vibrating systems. Alternatively, it can be intermittent depending on specific manufacturing processes that might start and stop throughout the day. The overall loudness of industrial noise also depends heavily on the specific machinery in use and nature of the operations being conducted. Often, industrial noise has a distinct hum or whirring quality that can be quite pervasive in surrounding areas. Now, let's turn our attention to significant negative impacts that noise pollution can have on our health and our daily life. It is not just an annoyance, it has real consequences for our well-being. One of the most well documented and pervasive effect of noise, particularly during nighttime hours, is sleep disturbance. Noise can disrupt our natural sleep pattern in several ways. It can prevent individuals from falling asleep in the first place, wake them up during the night, or reducing the overall quality of their sleep without fully waking them. This happens Because our auditory system, our sense of hearing remains active even when you are asleep. Sudden or loud noises can trigger psychological arousal responses in our bodies, leading to fragmented sleep. Lighter sleep stages are simply not enough restful sleep. The consequences of chronic sleep disturbance can be significant, affecting everything from our mood, cognitive function to long-term physical health. Another serious health consequence of chronic noise exposure is its link to cardiovascular problem. It might not be immediately obvious, but sustained exposure to high level of noise can actually contribute to an increased risk of various heart-related issues. The reason for this connection lies in how our body reacts to noise. Noise acts as a stress. When we are constantly subjected to loud or disruptive sound, it activates the body natural fight or flight response. This psychological reaction leads to several challenges, including an elevated heart rate, increased blood pressure, and the release of stress hormones. While these are normal responses to immediate danger, over a period of time, sustained activation of these systems due to chronic noise exposure can have damaging effect on cardiovascular health. This sustained psychological response can contribute to development of hypertension, also known as high blood pressure, and other heart related problems in the long run. Beyond the physical health aspect, constant or intrusive noise can also take a significant toll on our mental and emotional well-being, leading to considerable annoyance and psychological distress. This is because noise can interfere with so many aspects of our daily life. It can make it difficult to have a clear conversation, disrupt our ability to concentrate on tasks, hinder our relaxation and enjoyment of peaceful moments, generally detract from our ability to appreciate our surroundings. Further, feeling of a lack of control over the noise exposure can amplify these negative emotional responses. When we feel powerless to escape unwanted sound, it can exacerbate feelings of frustration and annoyance, potentially leading to more serious issues like anxiety, increased irritability. Some cases even contribute to the development of depression. Let I conclude that is this lecture covered common machinery noise sources in industrial settings, including gas jet, fan, compressor, electric motor, woodworking machines and pneumatic tools, explaining their noise characteristics and mechanism. Many industrial machines produce high noise level, posing hearing risk, but control strategies like silences and vibrations can help. At the end, the video lecture also covered the main causes of noises in cities and what are the health issues happening in city. Thank you for again engagement throughout this lecture. If you have any further questions or want to delve into specific aspect in more detail, don't hesitate to ask. We will see in the next lecture video.